Welcome to The Explainer. Today, we're going to tackle three fundamental concepts in statistics that, honestly, you probably use way more than you think: mean, median, and mode.
So let's kick things off with a problem that pretty much all of us face every single day, whether we realize it or not.
I mean, think about it. We're constantly surrounded by long lists of numbers. Your kids' test scores, the prices of homes in your neighborhood, how much screen time you got this week. So the big challenge is, how do you take all of that information and just boil it down to a single meaningful number that actually represents the whole group?
Okay, so let's dive into how we actually do that. To find that one single representative value, we've got three main tools in our statistical toolkit.
Yeah, I know. That's the fancy technical term for them, measures of central tendency. But don't let the name fool you. All it really means is that these are just different ways of finding the center, or, the most typical part of our data. You can almost think of it as finding the data's center of gravity.
First up is the one we all learned in school, the mean. This is what most of us are talking about when we say the average. And it's super straightforward. You just add everything up, and then you divide by how many things you added. Simple as that.
Next, we've got the median. The key word to remember here is middle. You literally line all your numbers up in order, from the smallest to the largest, and the median is the number that's sitting right there in the physical middle of that line.
And our third tool is the mode. The mode is all about popularity. It's just the number that shows up most frequently in your list. And I gotta say, I love this little memory trick from our source material. Just think of mode as the most often data entered.
So theory is great and all, but let's actually see how these three tools work in practice. We're going to use the exact same small set of numbers for each one.
All right, here's our sample data set. It's nice and simple. The numbers are 3, 2, 0, 5, and another 2.
First up, the mean. Step 1, we add them all up. 3 plus 2 plus 0 plus 5 plus 2, that gives us 12. Step 2, we divide by how many numbers we have, which is 5. 12 divided by 5 is 2.4, so our mean is 2.4.
Now for the median. And remember, this first step is absolutely crucial. You have to put the numbers in order first. So our set becomes 0, 2, 2, 3, and 5. With 5 numbers in a row, the one in the middle is the third one, and that number is 2. So our median is 2.
And finally, the mode. What's great about this slide is how clearly this bar chart shows you the answer. It plots how many times each number appears, and you can see that the number 2 has the tallest bar by far. Why? Because it appears twice, more than any other number. So our mode is 2.
So they all seem pretty straightforward, right? But this is where the real story begins. Things get a lot more complicated, and frankly, a lot more interesting when we introduce an extreme value into our dataset, something that statisticians call an outlier.
Let's use a real-world example to see what I mean. Imagine a small company with 5 employees. Now, 4 of them are making a solid $30,000 a year, but their supervisor is making $150,000. That super high salary is our outlier.
Now just watch what happens to our numbers. The mean salary suddenly jumps all the way up to $54,000, but the median, it stays right there at $30,000. That's not just a small gap, that's a massive difference, and it completely changes the story of what it's like to work there.
So let me ask you, which number do you think gives a better, more honest picture of a typical salary at this company? Is it the mean of $54,000, a number that's higher than what 80% of the employees actually make? Or is it the median of $30,000?
In this example just perfectly illustrates the core issue here. As our source material puts it, the mean's biggest weakness is that it gets pulled around by these extreme values. That one huge salary of $150,000 literally dragged the entire average up, making it seem like the typical salary is much, much higher than it really is for most of the people there.
So the crucial point here is that there's no single best measure. It really all depends on your data and what story you're trying to tell. Knowing the right tool for the right job, that's everything.
Think of this chart as your cheat sheet. You want to use the mean when your data is pretty evenly spread out, no crazy high or low numbers. But the second you have outliers, like that superstar salary or a ridiculously low test score, the median is your best friend because it doesn't get affected by them. And the mode? That's perfect when you just want to know the most popular choice, like the best-selling t-shirt size or the most common vote.
So, let's wrap this all up and look at the key things you need to remember.
Okay, if you remember anything from this explainer, let it be this. The mean is your classic go-to average, but just be careful. It's super sensitive to those extreme values. The median is tough, it's robust, and it gives you a better picture when your data is skewed one way or the other. And the mode simply tells you what's most common or popular. See? Each one tells a different but equally important part of the story.
And that leads us right to our final thought. Finding the center of your data is a fantastic start, but it really is only one piece of the puzzle. The very next question you should ask is, okay, but how spread out is the data? Is it all bunched up tightly around that center, or is it all over the place? But that, well, that's a topic for another explainer.